The second methodology for identifying your location we'll discuss is triangulation, where you utilize known locations and angles to identify your position. And there are several methodologies for doing that, including geometry, surveying, and map and compass. When using geometry, you calculate the unknown position using two triangles to known positions. And this methodology was developed by Greek philosopher Thales, where he estimated the height of the pyramids. If you look at the image on the right, you can see there are the pyramids right there, and he wanted to estimate the height of them. And so the process he came up with was taking a stick or a rod of a known length, that's A in this image, and putting it in the sand next to where the pyramid was. And then he waited till the sun was at a certain position that it cast a shadow in which the length of the shadow was the exact same as the length of the rod. Once he could do that, then he could measure the shadow from the pyramid, from the center of the base of the pyramid out to the end of the shadow. And if he did that, he knew what the height of the pyramids was. So really amazing way to use geometry to calculate your position, and in this case, the height of the pyramids. Now, surveyors utilize triangulation to calculate their position using the measured baseline between two known points and the angles to the unknown position. So it's all about the angles in surveying. And in the example on the right, you can see, for example, a ship at sea in which you don't know the location of the ship at sea, but you do have two known locations, in this example, A and B, and you know the angles between A and B and the ship from both A and B. And you can utilize that to create a right triangle in which you can calculate the distance of the ship from the shoreline. Now, surveyors utilize this same methodology and build out a network of triangles that they can use to map really large distances, for example, from Paris to London in Europe. Now, the last form of triangulation that we'll discuss is map and compass. And when you use map and compass, you're calculating an unknown position at the intersection of three bearing lines. Now, this slide steps you through the process of calculating your position utilizing triangulation and a compass. The first step is to align the map and the compass to the north. So if you look in the bottom left-hand image, we have a landscape there in which we have a mountain, that's Baldy Peak. On the lower right-hand corner, you can see a waterfall, that's Beaver Falls. And in the left-hand corner, you can see a boat ramp. And so since I have those three known positions, I can take my map in which they're located and orient my map to the landscape. So in this case, line up Beaver Falls with Baldy Peak and the side of my map. Once I do that, then I'm on to step 2, where I can find 3 landmarks in the field and label them 1, 2, 3 on the map. So I've already picked out my landmarks and I labeled them 1, 2, 3 on the map for Boat Ramp, Baldy Peak, and Beaver Falls. Now I'm ready to use my compass. And so I utilize my compass to set a bearing to landmark 1, and then I transfer that bearing line to the map. And if you haven't used a compass before, you position your shoulders and the compass and point it at the object you're interested in. In this case, it happens to be the boat ramp. And then you rotate the housing so that the orienting arrow surrounds the magnetic arrow. When it does that, then you know your bearing to that object. And you can transfer that from the compass, lay it on your map, and then draw a straight line from the, in this case, the boat ramp towards the bottom of the map where you know you're generally located. You'll repeat this process for landmarks 2 and 3, and that results in not just intersecting lines, but 3 intersecting lines that create a smallish triangle. It's within that smallish triangle that your position is located. And you can do this if you are pretty meticulous about it. You can really get your position to within about 50 to 100 feet of your actual location. The last methodology we'll discuss for identifying your location is trilateration, where you observe known locations and use distances to identify your position. And there are different approaches for doing that, including geometry, radio signals, and global navigation satellite systems. Now, the geometry for trilateration is where you calculate 2 unknown positions using 2 or more distances to known positions. And if you look at the diagram on the right, you can see I have C1 and C2. And C1 is a known position and C2 is. And if I know the distance away, for example, from C1, but I don't know exactly where my position is, I can draw a circle utilizing the radius of that distance all the way around, and that gives me circle 1. And then I can do the same with position C2 to draw circle 2. And then where those two circles intersect, it creates 2 points. And typically we discard the ambiguous point, which is the point, for example, on the other side of the ocean or on the other side of the world, to then calculate our position, in this case, P. Now we can utilize this same process to calculate our position utilizing radio signals, in which we calculate our unknown position using the time radio signals travel from two known positions. And so some examples of radio signals being utilized to calculate your position, including LORAN and emergency 911. And so if I have my phone and I make a call to 911, but I don't have any GPS associated with my phone, they still can calculate my position within, roughly 100 to 200 feet. And they can do that because my cell phone tells them which cell towers that I'm getting the signal from. And since it knows which cell towers, it knows the position of those cell towers, and it knows how long it's taking for the signal to get from each of those cell towers to my phone. And so you end up with intersecting circles, 2 points, and then you discard the ambiguous point and calculate the position within a couple of hundred feet. LORAN works that way too, which is a mariner's radio system for calculating location. And you can see an example of how LORAN works in the lower right-hand corner, in which you have a known position for 2 radio towers, secondary 1 and secondary 2. And then you have a master that's communicating out the signal to the LORAN radio on the boat. And so where those line of positions intersect based on the amount of time it takes for the radio signal to reach the boat is where the position of that boat is. In this case, again, the ambiguous point is somewhere on land, and so we know we can throw that out, and it's the point that's out in the ocean. Now, the last approach we'll discuss for trilateration, and really the focus of this topic, is the Global Navigation Satellite System, or GNSS. And that's where we calculate our unknown position using the time radio signals travel from 3 known satellite positions. So here you can see a couple of diagrams that step us through the process of calculating our position utilizing a global navigation satellite system. First, instead of a circle, we actually have a sphere because a satellite operates in 3-dimensional space. And so if we know where the satellite is and we know the distance it takes for the signal to get from the satellite to the GPS receiver, then we know we were somewhere located along that sphere. And if we find 2 satellites, then we can intersect those spheres and it creates an ellipse. So with 2 satellites, you know that your position is somewhere along that ellipse. Then when you add a 3rd satellite, you can calculate a 2-dimensional position in which the 3rd sphere intersects the first 2 to identify 2 points along the ellipse where the possible position is. And typically with GPS, you can throw out one of the positions because it's out in space. And so you know that your horizontal position is at this XY location on the Earth. Now, in global navigation satellite systems, we utilize 3 satellites to calculate a horizontal position, but the vertical position typically is so bad that we utilize a 4th satellite to refine the position so that we get a 3-dimensional position. And that 4th satellite uses a little trick. What it does is we assume that the position that we've established with the 3 satellites is correct, and we know where those 3 satellites are. So when we introduce the 4th satellite, we know where it is, and if we assume our position is correct, then we know how long it takes for the signal to travel from that 4th satellite to the receiver. And when it doesn't arrive on time or arrives too late, then we know that that is the error in our position. We can utilize that to refine our position and calculate a 3-dimensional vertical position.